Hello everyone, this is Mr. McMillan and I'm here with an instructional video on the first part of our quadrilaterals. And what we're going to be doing today is learning how to identify and classify quadrilaterals based on their properties. Now in the previous lessons we talked about how to determine interior and exterior angles of polygons, as well as what made a polygon. And now we're going to be looking at a specific subset of those, which is the quadrilaterals. So a quadrilateral is a polygon that has 4 sides. This also means that a quadrilateral has 4 angles. So a quadrilateral, we talked about this, has 4 sides, 4 angles. Okay. And the sum of the interior angles of a quadrilateral is 360 degrees. And we learned that because we took the sum and it was n minus 2 times 180, where n is the number of sides. So you'd have 4 minus 2 times 180, which gives you 360. Okay, so those are the basic properties of quadrilaterals. If you have a polygon with 4 sides, it's a quadrilateral. It doesn't matter what it looks like. It doesn't matter whether it's convex, concave. As long as it has 4 sides, it's a quadrilateral, okay? However, there are 6 types of quadrilaterals with their own properties we're going to talk about. Now, there are 7 technically, but we don't discuss that one, and that is a kite. We'll talk about that at the very end. But the ones we're going to focus on are the trapezoids, parallelogram, rectangle, square, and rhombus. So what we're going to do is we're going to fill out this chart of properties for each shape. And when we fill out this chart, we're going to be labeling our diagram as we go along. Okay, so the first shape is a trapezoid, and the first property that it has is that it has 1 pair of sides. It has 1 single pair of parallel sides. So if we look at this diagram over here, we have a trapezoid here, A, B, C, D, and what sides are parallel to one another? Well, as we can see, AB and DC are parallel to one another, and remember, you can either use the little chevrons or you can use the triangles. Most people do the chevrons because it's quicker. I'll be doing that for the other ones, but just to show you, you can use triangles to indicate they're parallel. Now, AD and BC are not parallel because of the fact that, well, as you can see, they're at different slopes, and if they kept going, they would eventually intersect. These, on the other hand, would not. So it only has 1 pair of parallel sides, never 2. All right, our second property, it has 2 sides called bases and 2 sides called legs. Now the bases are what it sits flat on, okay? So the bases are always the parallel sides. And we actually call this one up here, the one that's towards the top, we call that the upper base. And we call the bottom one the lower base. Okay? So, next property, the last property trapezoids have, each lower base angle is supplementary to each upper base angle on the same side. Now, we talked about that when we did parallel lines and transversals, and we talked about the reason, we actually did some problems with trapezoids, and we talked about the reason that angles A and D would be supplementary and B and C would be supplementary, and that's because they are same side interior angles. Okay, they are same side interior angles, and same side interior angles were always supplementary. Okay, So down here underneath the trapezoid, I'm going to write that statement here. So A and D are supplementary. So the measure of angle A plus the measure of angle D equals 180 degrees. And then the measure of angle B plus the measure of angle C is equal to 180 degrees. Now note, A and B added together do not equal 180. Same thing with D and C, okay? All right, so that's trapezoids. Trapezoids, one pair of parallel sides, and the angles that are basically above or below one another are supplementary, not across, but above and below. Next up, we're going to talk about a specific type of trapezoid called an isosceles trapezoid, okay? Now, just like a regular trapezoid, the first property is that there's one pair of parallel sides, okay? And similarly, we see that in this diagram, we have AB and DC are parallel. All right. Now, how this type of trapezoid differs from a regular trapezoid, like a general case trapezoid, is that there is one pair of congruent sides. And this pair of congruent sides are the legs. So the legs are congruent. And remember, we talked about what isosceles meant when we classified triangles. And that was, it had a triangle that was isosceles had at least two sides that were congruent and two angles that were congruent, and it's similar here. It has two sides that are congruent. All right. 3, the lower base angles are congruent. So down here on this lower base, DC, angle D and angle C are congruent. So we're going to put our little angle markings on angle D and angle C. But not only are those two congruent, but the upper base angles are congruent. Now note that A and D are not congruent and B and C are not congruent, okay? But A and B are congruent and D and C are congruent. Okay, and do remember that that A and D, since this is a trapezoid, measure of angle A plus the measure of angle D would equal 180, and the measure of angle B plus the measure of angle C would equal 180. Okay, so that doesn't change. All right. And then the last property that's unique to an isosceles trapezoid compared to the original trapezoid, the diagonals are congruent. So the diagonals are the same length. So if we take our diagonal here, and I'm going to draw it in red, and I will try to draw it as straight as I can. Those two red lines there are congruent. So AB, or sorry, not AB, excuse me, AC is congruent to BD. So the diagonals, the length of those diagonals are congruent. All right, next up, parallelogram. You guys should be somewhat familiar with parallelograms, but we're going to dive deeper into, what makes a parallelogram. So the first property that parallelograms have is that the opposite angles are congruent. So Opposite means they're ones that do not touch one another. They're not connected by a side. So for instance, which angle would be opposite from angle A? Would it be B, C, or D? Well, it's the one that does not have a line connected to it from those angles. So A is opposite of C. So that means that A and C are congruent. So angle A is congruent to angle C. Is there another pair of opposite angles here? Yes, there is. You have B and D. Those would be congruent to one another. So angle B is also congruent to angle D. All right. Consecutive angles are supplementary. Now, what it means by consecutive angles, they're angles that touch one another, okay? So they're angles that are connected by a side. So for instance, angle A and angle D are consecutive because there's a line that connects A and D together. So we would say that the measure of angle A plus the measure of angle D is 180. Now, you can also see that D and C are connected, so D and C would be supplementary, C and B would be supplementary, and A and B would be supplementary. Okay, we'll be working with this a lot. You know, today's mostly focused on getting those properties down and classifying them, and then we'll worry about the finding of the angles and sides in a bit. All right, this next one. A parallelogram has two pairs of parallel sides. And as you can see here, you would have AD and BC would be parallel. And then AB and DC would be parallel. And not only are the two pairs of parallel sides, or two pairs of sides parallel, but they're also congruent. Okay. And so they're congruent. The opposite sides are congruent. Okay. And the last one, the diagonals bisect each other. Diagonals bisect each other. So if you take your bit here and you draw your diagonals, that's a very poor diagonal, but you get the point. Now, unlike the trapezoid, for a parallelogram, the diagonals are not congruent. Okay, the diagonals are not congruent. However, they do bisect each other. And what that means is that they split each other in half at the intersection. So right here, this point of intersection right there, each one of those is now bisected. So this is congruent to this, and then this is congruent to this. Now I know there's a lot of symbols there and everything else. Don't worry about that too much. All you need to know is that the diagonals are not congruent, but they do bisect each other. So the parts here are equal, the parts here are equal, but these aren't necessarily equal to one another. Okay? Like I said, we'll be doing a lot of these in the future. All right, let's look at rectangles. All right, so rectangles. You guys should be familiar with rectangles as well. And a rectangle, the very first property that everybody should know is that every angle is a right angle. Okay, so every angle in a rectangle is a right angle. And of course, that means that each angle measures 90 degrees. So each angle should be 90 degrees. So we're going to put the little corner marking on each one. Okay. Next, the diagonals are congruent for a rectangle. So for a rectangle, the diagonals are congruent. So that means that if we draw our diagonals here, and again, I'll try and draw them as straight as I can. We can say that AC is congruent to BD in this case. Okay. But that's not all about the diagonals, because the diagonals are not just congruent, but they bisect each other. They bisect each other. So since these are congruent and they bisect each other, we can actually say that these parts are congruent to one another. Basically, let's say that one of the diagonals was 10. And that would mean the other diagonal's 10 as well because they're congruent. Well, if you bisect it, that means you split it in half. So this would be 5, this would be 5, this would be 5, and this would be 5 because they have to split each other into equal parts. Okay. All right. And then the last thing, it can be classified as a parallelogram as well. This means it also has the same properties as the parallelogram. So what makes a parallelogram? You have the two pairs of parallel sides and two pairs of congruent sides. So these two would be parallel. These two would be parallel. These would be congruent. And these would be congruent. Okay. Like I said, the markings, they're just telling you that something's congruent, parallel, whatever else, okay? We're going to be filling out a chart for this in one of the future lessons, so should be a little bit easier at that point. All right, so that's a rectangle. All right, now we're moving on to a rhombus. And for a rhombus, the very first property a rhombus has is that there are 4 congruent sides. 4 congruent sides. So here AB is congruent to BC, congruent to CD, and congruent to AD. So we put a marking on all of those. All right, next up, it says blank angles are congruent. So just like a parallelogram, the opposite angles are congruent, okay? So A would be congruent to C. And angle D would be congruent to angle B. All right. All right, so opposite angles were congruent, and just like a parallelogram, the consecutive angles would be supplementary, okay? So that would mean that A and D would be supplementary, D and C would be supplementary, C and B, and so on and so forth, okay? Next up, the diagonals are perpendicular bisectors. So remember, perpendicular means they intersect at right angles. And the important thing is that they also bisect the angles, okay? So when you take your diagonals here, You take your diagonals there. Since they're perpendicular, they intersect to form a right angle. And it says they're bisectors, so they bisect one another as well. But I do want to note that these diagonals are not congruent. Okay, so in a rhombus, the diagonals are not congruent. However, they do split each other into separate bits. And they also bisect the angle. That means the diagonals split each of those angles in half when they're there. So whatever those angles are on the left and right side of the diagonal, those are equal, okay? That'll be important when we talk about that, but you know, we'll get there. And just like the rectangle, it can also be classified as a parallelogram. Okay. And then our last shape that we're going to be talking about in detail, and it's the one, you know, that everybody should be relatively familiar with, is a square. And just like a rhombus, a square has 4 congruent sides. So all 4 sides are congruent. And just like a rectangle, a square has 4 right angles. Okay, so all 4 sides are congruent. And all 4 angles are right angles. Okay, additionally, our diagonals here, and again, I'm going to try and draw this as straight as I can. That one wasn't too bad. The diagonals are congruent, so that means the AC is congruent to BD. All right. Next up, the diagonals are perpendicular bisectors, which again means that they form a right angle there, and they bisect one another. And since they're congruent, we know all of these are the same. And additionally, it also bisects the angles, just like a rhombus does. So if you bisect that 90-degree angle, you cut that 90-degree angle in half. So what would each of these angles around those diagonals measure? Well, that would be 45 degrees. So each one of those is 45 degrees. Now, you know, it's good to have these written down or, you know, draw out these pictures. Just make sure that you can identify these properties. And a square can also be classified as a parallelogram, rectangle, and rhombus. And the reason it can be named that, a rhombus has 4 sides, 4 congruent sides, opposite angles congruent, diagonals are perpendicular bisectors and bisect. A square has all those properties. The only other thing that it needs for the rectangle is the right angles and the congruent diagonals, which it has. And then of course it's a parallelogram because it has 2 pairs of parallel sides and 2 pairs of congruent sides. So this Venn diagram here is basically a summary of how these can be classified. So if you find out that something can be a square, for instance, you know that it has to be everything else as it gets, you know, higher levels. So our first big bubble here, this is all of the quadrilaterals. All of the quadrilaterals. So this is any 4-sided shape. Any 4-sided shape goes in this big circle, okay? Now, on the left side here, we'll come back to that, but on the right side, we have 2 bubbles here. The first, we're gonna label with a trapezoid. So there's a set of quadrilaterals that are trapezoids, okay? And of course, this also includes the isosceles trapezoids, which would be a smaller bubble in here if we wanted to be technical. The other one we didn't talk about is a kite, okay? Now, I just need you to know that a kite exists. A kite looks like this. Well, it looks like a kite, where these are congruent and these are congruent. But we are not going to be working with that too much, okay? So trapezoid plus isosceles and a kite. Now you'll notice that these two bubbles do not intersect. That means that trapezoids will never be kites and vice versa, okay? So make sure you're aware of that. If something isn't inside of another bubble or touching it at least a little bit, sharing a side and sharing a space like this one is, then whatever's there cannot be that other thing, okay? Now the other big bubble here we have, this bubble here, we're gonna label that as our parallelograms. So we've got a bunch of shapes that can be parallelograms from our quadrilaterals. Now, in the parallelograms, there are 3 different things that can be classified as parallelograms as well, okay? The 2 more generic ones are the rectangle and the rhombus. So this circle here represents the rectangle. This circle here represents the rhombus. It's just like when you did these in English class. And in this shared space, we're going to put the square. And what this means is that a square is all of these things here. So a square is a rhombus and a rectangle and a parallelogram and a quadrilateral. But it's not a trapezoid because it doesn't share any space with the trapezoid bubble. Similarly, a rhombus is always a parallelogram, but it's not always a square or a rectangle. It shares some spaces with that, but it's not always that. So if a bubble is completely contained in another bubble, that means that that shape is always the one for the bigger bubble. So a rectangle is always a parallelogram, for instance. A parallelogram is always a quadrilateral, and so on and so forth. Okay? So that does it for the instruction part. Now we're going to look at some examples. So these first ones want us to complete the true-false statements about quadrilaterals. And these true-false statements are basically saying, something is sometimes, always, never, whatever, and comparing the shapes. So let's look at the first one. The first one says all squares are rectangles. Would that be true or would that be false? Well, if we look at our Venn diagram, for all squares to be rectangles, the square bubble would have to be completely contained within the rectangle bubble. And is the square bubble completely inside of the rectangle bubble? You should see that yes, the square is indeed inside the rectangle. So that means that a square is always a rectangle. So all squares are rectangles is true. All right, next up, a trapezoid is sometimes a parallelogram. So, you can try all these on your own and check yourself. So again, you can refer back to this Venn diagram. A trapezoid is sometimes a parallelogram. So if it's sometimes a parallelogram, but not always, it has some overlap between the parallel bubble or parallelogram bubble. So let's look. Here's the parallelograms. Here's the trapezoid. Do these have any overlap? The answer is no, they do not have any overlap. So that means that these shapes can never be one another. So a parallelogram can never be a trapezoid, and a trapezoid can never be a parallelogram. So this one would be false. So it can never be a parallelogram. So it can never be a parallelogram. And vice versa. A parallelogram can never be a trapezoid. All right, next one. A rhombus is always a square. Is that true or false? That one would be false. If you look here on your diagram or your Venn diagram, here's your rhombus bubble. It's this big bubble here, and here's your square bubble. The square is completely contained within the rhombus bubble, but the rhombus bubble is not completely in the square. So that means there are some rhombuses that are not squares, okay? So it's sometimes a square, but not always. So sometimes, but not always. All right, number 4, all rectangles are parallelograms. So is that true or false? Are all rectangles parallelograms? This one should be true. And again, you can refer to your Venn diagram. You'll see that the rectangle bubble is completely inside the parallelogram bubble. All right, so try numbers 5 through 8 on your own. Use that Venn diagram if you need to do, the true false statements, and then come back and check your answers. All right, so number 5, all parallelograms are rectangles. This one would be false. If you look at your Venn diagram, the parallelogram bubble contains the rectangle completely, but you see there's some open space here. That would mean that there's some parallelograms that are not rectangles. So all parallelograms are not rectangles, but sometimes they are. So sometimes, but not always. Number 6, a parallelogram is sometimes a square. That would be true. The square bubble is completely contained in the parallelogram bubble, so that means that some parallelograms are squares, but of course not all of them are. Number 7, a rectangle is always a square. That one would be false. And if you look at your Venn diagram, a rectangle being a square, it's the same situation as the rhombus. The rectangle has some open space that's not taken up by the square, so that means some rectangles are not squares. So it's sometimes, not always. And then number 8, a rhombus is sometimes a rectangle. That would be true, because if you look at your Venn diagram, you see that the rhombus circle does intersect with the rectangle circle, and that space in, if a rhombus is a square, then it's also a rectangle. So sometimes a rhombus is a rectangle. Okay? All right. These next examples here are classifying the quadrilaterals. And what it wants us to do is state all names for the figures given below. Okay, so state all names for the figures. So if it's, for example, a parallelogram, then that also means it's a quadrilateral. So you would write both of those names down. Okay. If it's a square, it would also be a rhombus, rectangle, parallelogram, and quadrilateral. So write all those down. So let's look at number 9. So number 9, we see that we have 2 pairs of opposite sides that are congruent, and we have 4 right angles. But not all the sides are congruent. So what shape would that be from the ones we talked about? Well, this one would be a rectangle. And are there any other things we could classify it as other than a rectangle? Well, again, Venn diagram, a rectangle. So it's just a rectangle, it's not a square. So a rectangle to a parallelogram to a quadrilateral. So we would name this a rectangle, parallelogram, and quadrilateral. Okay. Number 10, what type of shape would that be? Well, we have two pairs of parallel sides, and it doesn't say they're congruent, but we can see they are congruent. There's no other way it would work. But not all four are congruent to one another, and these angles are not right angles. So this one would just be a parallelogram, but is there something else that we could name it as? Absolutely. A parallelogram is also a quadrilateral. If you haven't noticed by now, if it has four shapes, it's a quadrilateral. So pretty much for any of these, quadrilaterals should be on there. All right, number 11. Number 11, we see we have one pair of parallel sides. So we automatically know that it's a trapezoid. Okay, so we know it's a quadrilateral because it's got four sides. And we know it's a trapezoid because it's got one pair of parallel sides. The only question is it an isosceles trapezoid? And remember, an isosceles trapezoid has one pair of congruent legs. Does this have one pair of congruent legs? Yes, it does. So this would also be an isosceles trapezoid. All right, number 12. Number 12, we see that we have a 120-degree angle. We can see that none of these sides are congruent, but we can see that these two sides here are parallel. So we've got one pair of parallel sides, which means it's a quadrilateral and a trapezoid. But is it an isosceles trapezoid? Well, are the legs congruent? And the answer is no. One's 14.7, one's 12.7. You could also tell by the angles. The lower base angles are not congruent and the upper base angles are not congruent. So this is just a quadrilateral and a trapezoid. All right, number 13. What type of shape is that? Well, it's got four sides, so we know it's a quadrilateral. And the question is, does it have any parallel sides? And here's the thing, if it doesn't have any parallel sides, then you can stop at a quadrilateral because all of the shapes that we're talking about need parallel sides of some sort. And we can see that none of these sides are parallel, okay? So this would just be a quadrilateral. All right, try number 14, 15, and 16 on your own, then come back and check your answers with the video. All right, so number 14, we see that we have four right angles and four congruent sides. So since we have four right angles and four congruent sides, we know this is a square. Now, all squares are rectangles. All squares are rhombuses, or rhombi, as some people like to say. Parallelogram as well. And of course, a quadrilateral. The only thing a square is not is a trapezoid. Okay, and we can tell that by looking at the diagram. We have the square in here, which is contained completely in the rhombus and rectangle bubbles, and the parallelogram bubble, and the quadrilateral bubble. All right, number 15. Number 15, we see that we have four congruent sides, but the sides or the angles are only congruent on the opposite sides or opposite angles. So four congruent sides means that we have a rhombus. Now, since this does not have four right angles, we can't say that it's a square or a rectangle, okay? However, a rhombus is a parallelogram. And it's also a quadrilateral. And finally, number 16. Number 16, we see we have two pairs of opposite congruent sides. Opposite angles are congruent, and the angles here are not right angles. So that means it cannot be a square or a rectangle. There are not four congruent sides, so it can't be a rhombus. But we do know that this would be a parallelogram because it has two pairs of parallel sides along with the congruence. So it's a parallelogram, and of course a parallelogram is also a quadrilateral. So that's going to do it for this video, guys. I hope this video helps. Please make sure to email me if you have any questions. You can also email Mr. Thompson, and we'll be more than happy to help you out as much as we can. Okay. Please make sure that you work on the worksheet that is based on this. The front side is similar to these, and then the back side or the second page is determining properties. Okay. So, you know, you would check all the ones that are congruent diagonals and so on and so forth. All right. Also, please make sure you're working on any missing work that you might have, just because, you know, it's important for you, because otherwise it's a 0 in the grade book. Thanks, guys, and I will see you in the next video.